All right, so it looks like we are up and rolling. I told you that we're going to start to make some of these notes and videos. I wanted to help you guys get through this real quick. First things first, reactants and products. The reactants are what we start out with. The reactants are what we start out with. The eggs, the flour, the milk, they will turn into the product. In this, the product will be the cake. Cake is product, it's what gets bought. We buy products. Okay, reactants are on the left. This whole equation is called the photosynthesis reaction or the photosynthesis equation. We start out with two chemicals, carbon dioxide, water. You might remember we called these molecules. These molecules are what we start out with. They react in a reaction. They turn into the products. The products are what we get out of the reaction. So the reactants turn into the products. Products are what get produced. Okay. We're going to say this about 16 million times, but matter can't be created or destroyed. Needs to be equal. We have one carbon right here on the left, one carbon in the reactants. Now we have one carbon in the products. If we have one carbon in the products, and now we have one carbon in the reactants and one carbon in the products. Sorry, got a little tricky. Now we have two reds right here. We have two oxygens in the reactants. We will have two oxygens in the products. Whatever we start out with is what we end up with. That's why we say that the reactants equal the products. Next, how many H's do we have here? Well, on the left, we can see that we clearly have four H's. If we have four H's on the left or on the reactant side, we had better have four H's or four hydrogens on the product side. The reactants equal the products, always. That's not something where it's going to change. It's not I before E except after C. If I have four H's on the reactants, there will have to be four H's on the products. After that, and it all comes down to can you count? We have four white circles right here. Well, that lets me know that I have four white circles on the left. There is one black sphere right here. That's carbon. There is one black sphere here where you're going to have the same on the left as we have on the right. And so this is our last strategy, if I want to go through and produce double the amount of a product, in some situations, it could be very useful if we produce another chemical. Right here, if I want to double the amount of carbon dioxide, I need to double the amount of methane. If I want to double the amount of carbon dioxide, I'm going to put a 2 in front, and we'll show you this in the next slide. If I want to double the products, double this side, I have to double the reactants. Remember back to math when we went through and you learned that if I put a 2 on one side, there had better be a 2 on the other side. It's the same thing. They actually came out with that idea in your math class so that they could do science. If I put a 2 on the front, I have to put a 2 on the back. So if we can remember that matter can't be created or destroyed, it will help us to remember that the numbers balance out. Okay, almost done. If I want 2 of these, I had better have 2 of these. That's going to end up creating 2 of these. So a double batch, final idea, if I want to make a double batch, I would have to have 2 sets of methane, 2 sets of oxygen, so 4 O2s total, 2 sets of carbon dioxide, and 2 sets of water, which would net me 4 waters. I hope that helps. This is 8.1.6, WADS Explains the Conservation of Matter. Thanks.